4 sections, which means what? There will be no quiz. We're going to go 11.1 all the way through 11.4. We're just going to take the test. We're not going to cut it out. Okay? All right. All right. So solid geometry. This is all review for you. Go to page. We are on page 742. 742. If you look there, there are 3-dimensional figures. There's a prism, cylinder, pyramid, and a cone. Okay, look through those. And what was the magic number when we talked about volume? Does anybody remember what the magic number is? Were you guys told that the magic number was 1/3? You guys didn't do this? So look at the cylinder versus a cone. What are the commonalities between a cylinder and a cone? What? Yeah, the base is a circle, right? On the prism and a pyramid, they have a base as what? What are the bases in the picture right there? It's a triangle, right? But the base can be really anything, right? You can have a square base, you can have a hexagonal base. You can put anything on the base that you want, right? Okay. So the difference between a prism and the pyramid, again, is one goes straight up, where one, that's the prism, the pyramid meets at one point on the top. Okay. So the magic number here that I always teach, the magic number is that the volume, the cylinder versus the cone, is 1/3. The cone is 1/3 of the volume of a full cylinder. Okay. Just the same as the prism and the pyramid. The pyramid, the volume of a pyramid, is 1/3 of a full prism. Okay, so that's the magic number, 1/3. Keep that in mind. Okay, if you know that, you're pretty much good to go for this stuff. Okay. Example number 1. Classify each figure. Name the vertices, edges, and the bases. I'm going to let you read through on your own. A, look at the picture, read through the answer of A. Okay. And that allows you to know from there, you can tell what a vertex is, what a vertex is, right? What a vertex is, what an edge is, and what the base is. Okay, so based on that, you can tell that a vertex is a point on that pyramid where the lines meet, right? We're basically where the edges meet, right? Right? The edges are the lines, right? And the base is the one on the bottom, really. That's all there is. Okay? Right? Look at the cylinder, same thing. On a cylinder, there are no vertex. Because they don't meet at any point, right? If it was a cone, you would have a vertex on the top, correct? This is a cylinder, so you don't have any. There are no edges because the base is circular, right? The base is circular, so there are no edges. Okay. Example number 2. Example number 2. These are basically spatial reasoning. So you have to look at that and look at that cardboard thing. And if I cut around the edges and then fold on the inner lines, what shape am I going to get? So on A, what shape am I gonna get? So you're gonna get a triangular prism, right? You're gonna get basically what you have on page 742, the top one. Does that make sense? But it's gonna be a longer one, right? Okay. Where would you use this type of thing? Anybody ordered like a art poster or something like that? You received it in that kind of thing before? And they're kind of shipping one of those things, or actually in a cylinder, right? And when you get an order a poster from somewhere or something like that, or you go to a museum and they give you something, right? So that's what the shipping box looks like. Okay, let's get B. Look at B. If I folded all those edges up, what am I going to get? It's going to be a, yeah, looks like a square here. We'll call it a square, right? A square pyramid. A square pyramid. Let's go to the bottom of the page. Check it out. 2A. What do I get from 2A? Triangular pyramid. Okay. What about B? It's kind of like a can, right? When you go to, if you take a can and you open up the top and then you cut it and you flay it open, right? This is what you would get. All right, flip the page. Let's go to number 3, example 3. Describing cross sections of the three-dimensional figures. A, if I cut this is a triangular prism, triangular pyramid. If I cut it parallel to the base, I'm going to also get a triangle, right? As a matter of fact, I'm going to get a similar triangle to the one on the bottom, right? It has to be the same shape, right? Different dimensions, same shape, right? B, again, if I do it parallel to the bottom of the base, I would get a what? What shape is that? B, we're on 3, example 3, B here. Reed, what do I get?
A cylinder?
Well, that is a cylinder. When I cut a cross section across there, what am I going to get?
Wouldn't it still be a cylinder?
A circle, right? Not a cylinder, a circle, right? The shape in the plane that you're cutting.
Oh yeah.
Okay, that is a circle, correct?
Yes.
What happens if I'm doing the same cutting, but I'm not cutting parallel to the bottom part, and I do it like this, a little off? Then what shape would I get? Anybody get that? No, I wouldn't. I heard it would be an oval, right? Because it's going to be a little tilted, which means that the circle is no longer a circle. Now it's going to be elongated on one side, right? So you would get an oval. Okay. Good job. All right, example number 4. Example number 4. You notice I'm not drawing all this up here because there's no way I draw it better than what they have. Hey, so example 4, a chef is slicing a cube-shaped watermelon. I've never seen in my life a cube-shaped watermelon. Has anybody seen a cube-shaped watermelon before? I have no idea. How do you grow these things?
Aren't they like extremely expensive? They're like the most expensive thing. And I'm pretty sure they're like.
Do you actually encase the watermelon in a square? In a box?
Yeah, they're like.
It grows in a box? But then it doesn't get does it get enough sun to ripen? Oh, it's a clear box. Okay, it's clear. Okay, yeah, okay, all right. I've never seen this before.
They're like super expensive.
Yes, they must be.
They are.
Okay, so whatever. How can the chef cut the watermelon to make a slice of each shape? Okay. A is easy. If you cut parallel to the base, obviously the shape is going to be the same square, right? Then you had the square, well, the base was a square, okay, that's easy. B, look at B. I'm gonna let you kind of mull that over a little bit. And it's hard to imagine you would actually get a hexagonal shape out of that, but you can. Okay? Look at that. So they tilted the way they're cutting it. They actually can get a hexagon out of that. Okay. So we are done here for the day. Let me go ahead and get your homework assignment up.